gas. So I repeat again, guys. Matter based on physical properties can be further divided into three basic states of matter, that is solids, liquids and gases. But guys, what do you think? Do we have only three states of matter? Okay, so can anyone tell me super Granth? Absolutely correct. Semi-solid. No, semi-solid is not a state. Plasma is the correct answer. Plasma is the correct answer. Perfect, Steve, Gaurangi, Urvi, Parth, Lavanya. Plasma is the correct answer. The fifth state, there are five states of matter, guys. When we heat solid, solid turns into liquid. When we heat liquid, liquid turns into gas. Fine. Exactly in the same way, when we heat gas, it turns into super hot gas, and that is called as plasma. I repeat, when you heat solid, it turns into liquid. When you heat liquid, it turns into gas. When you heat gas, it turns into super hot gas, which is called as plasma. When scientists came to know that there is something called as plasma, there is something called as super hot gas, exactly on the same lines. Exactly on the same lines, we also have super cool gas. I repeat, the way we have super hot gas, we also have super cool gas. There were two scientists, the team of two scientists, Mr. Bose and Mr. Einstein. They found out artificially prepared states of matter, which is famously called as Bose-Einstein condensate. I repeat, Bose-Einstein condensate is the fifth state of matter, which is again a gas, but it's a super cool gas. The temperature of this gas is going to be at a very low side. But unfortunately, the existence of the state, which was found to be hardly for some minutes, or rather, I would say few seconds, and because of that, people could not study its properties, its basic characteristics, and hence we say it is still under research, it is still under process, it is still under uh, study. So we don't study Bose-Einstein condensate at all, and plasma धरती पे होता नहीं है. One of the best example of plasma is sun. Yeah. So again, even plasma is not studied as such. Our syllabus is concerned. We study only three states of matter, that is solid, liquids and gases. So here we have few basic examples on the screen also. We have, yes, Harsh, it is a part of matter. We can say that because ultimately it is one of the state of matter. Uh, Parth, it is still under understanding. If you're talking about plasma, it is in space. Of course, that is sun, as well as there are some stars. We say they are super hot gases. But people says that Bose-Einstein condensate is yet to be studied. Virat, I get your chats, Virat. So don't worry, I get your chats. Okay, so in a very simple terms, plasma and Bose-Einstein condensate is not present on the Earth as of now. And as far as Bose-Einstein is concerned, it is still under study, it is still under research. Okay, so here we have solids, these wood, we can call it as solid, tent, all tree trunks, etc. We have water, that is lake, it is again liquid state, and we also have air, so it is gaseous state. Yeah. Moving a step further, based on chemical properties, I repeat again, based on chemical properties, matter is further divided into three characteristics, three categories here. To begin with, here as we can see on the screen, there is a picture where coal is burning. And when you burn coal, of course, we get a black smoke out of it. And at the end, we'll be left with a black color powder, to which we call it as ash. Now, what must be there in this particular coal? Well, coal consists of one element, that is carbon. One single element, that is carbon. Now, why do I call it as element? To understand this, let's understand another example. Imagine I have an iron rod. Okay. If I have iron rod, we all know the basic characteristic or a unique property of iron. Iron gets attracted towards magnet. Now imagine I break this iron rod in two halves. So what do you think? Will it still attract towards magnet? If I break iron rod in two half, absolutely correct Parth, Namasri, Gaurangi, Radesh, absolutely correct Rich Steve, perfect Virat. It will definitely get attract. No Shaurya, it will attract towards magnet because we have just uh, we have just broken it into two halves. We have not done anything else. We have just broken it into two halves, and it is iron, purely iron. So iron को जितना भी break करोगे, ultimately उसमें से iron ही मिलने वाला है. You may cut it into two halves, four halves, or you may cut it into 8 pieces, or maybe more than that. You may divide into fine powder. It will still get attract towards magnet because that is a unique property of iron. In a very simple terms, when you apply any sort of breaking or any sort of division, it cannot be further divided into simpler form because iron itself is the simplest form of a matter, the purest form of a matter. Exactly in the same way, carbon, hydrogen, nitrogen, these are elements because elements are the purest form of the matter. So purest form of the matter, which is indivisible further, which cannot be further subdivided into simpler form, is called as an element. So element is something which cannot be further subdivided. Okay. Now, suppose if I talk about, uh, let's say two element, that is hydrogen and oxygen. Okay. So I'm taking hydrogen and oxygen. So hydrogen can be written as H2, oxygen can be written as O2. When we add this two together, I will get H2O. Fine. So this is H2O. All right. Now we all know few important properties of hydrogen. When I talk about hydrogen, guys, we already know that hydrogen burns. When I talk about oxygen, we all know that oxygen supports burning. But guys, we already know that water subsides the fire. It neither burns, it doesn't support burning, rather it subsides the fire. So what am I trying to say? Though hydrogen and oxygen are combined together, though hydrogen is a part of water, though oxygen is a part of water, the important property or the characteristic of hydrogen and water doesn't match. Oxygen and water doesn't match. So this is first important point about the word which we are going to learn. Absolutely correct, Urvi. The second point, the most important point, you can see hydrogen and oxygen when combined in water, it has a fixed proportion here, 2 hydrogen, 1 oxygen. By weight or by number you talk about, they have fixed number of elements, they have fixed number of atoms present in it. Now you may take river water, you may take lake water, you may go in, you may go to Antarctica, you melt that glacier ice and you take water out of it. Ultimately, it is going to be H2O only. Fine. No, Ronit, it should not be. Why, that we will understand little later. It has to be H2O. We cannot write H2O2. We cannot write 2HO. That is completely wrong. Why, that we will understand little later. Water is H2O. Formula of water is H2O, where 2 hydrogen atoms and 1 oxygen atom is there. Okay, so that has to be like that. Okay. No, Shaurya. Uh, whichever water you talk about, ultimately water is H2O. हाँ, जैसे हम sea water की बात करते हैं, तो in sea water we definitely have little amount of salt in it, but it is mixed. It is not combined. When I say combined, hydrogen and oxygen are chemically attached, chemically combined. That means when I take water, if I give you a glass of water and if I ask you just take oxygen out of it, is it possible, guys? Is it possible? Of course, no. Why? Because hydrogen and oxygen is chemically attached. They have a bond between, they have a force of attraction between them. So you cannot break that easily just by simple physical process. If you want to break it, you need to supply some chemical reaction. You need to do some chemical process with the compound. So what is compound? It is the combination of two or more elements chemically combined in a fixed proportion. I repeat, when two or more elements chemically combined in a fixed proportion is called as compounds. So what are compounds, guys? It's very simple. I'll take again the example of carbon itself. जब मैंने carbon को burn किया, it went and combined with oxygen to form carbon dioxide. So again, चाहे हम हमारे घर के कार्बन डाइऑक्साइड की बात करें, बाहर के कार्बन डाइऑक्साइड की बात करें, अमेरिका जाके वहां के कार्बन डाइऑक्साइड की बात करें, any place you talk about, carbon dioxide is going to be CO2 only. So it's a fixed proportion. Fixed amount of carbon and oxygen is combining together to give us carbon dioxide. So compounds are made up of two or more elements chemically combined in a fixed proportion. Okay. Now we are moving to the third word, and that third word is, when I talk about air, air consists of nitrogen gas, oxygen gas, hydrogen gas, carbon dioxide gas. There are so many gases present in air. Okay, let us understand this word with the help of a relatable example. Guys, हम भेल खाते हैं. Okay, so जब हम भेल खाते हैं, भेल में कुरमुरा होता है, सेब होता है, there's tomato, there's a potato, there's onion, there are a lot of spicy chutneys, या फिर बहुत सारी चीजें उसमें include होती है. But every individual thing present in bhel has its own characteristic, has its own taste also. Fine. So exactly on the same ground, guys, even air consists of so many gases with a different proportion. We all know the nitrogen is present in the highest proportion in air. Oxygen ratio is somewhere around 20% approx. Fine. So in a way, there are so many gases, but every gases are present in their own proportion. Every gases possess their own characteristic. Oxygen air में बैठकर burning को support करने का काम करता है. हाइड्रोजन burn होने का काम करता है. कार्बन डाइऑक्साइड subside करने का काम करता है. So there are every gases with their own characteristics. So this is called as mixture. What are mixtures? Where elements or compounds are mixed together in any proportion. Elements or compounds are mixed together in any proportion is called as mixture. So this was something really very basics. You must have studied this in your 8th standard also, guys, that elements, compounds and mixtures are the part of matter. Okay, we understood few basic definitions of it. Moving further, guys, to the next important point, the next important term. Okay, we will not go in much detail, but long back in 6th century, long back in 6th century, we came to know that everything in our surrounding is made up of small particles. Yes, guys, I'm talking about way back in 6th century, and we should proud on ourselves because the statement was given by an Indian philosopher. The beginning of chemistry was done in India by Maharishi Kanat. Maharishi Kanad was the one who named it as Parmanu. Absolutely correct, Parth Virat. He had named it as Parmanu. Correct, Namasvi. He had named it as Parmanu. Parmanu is a Sanskrit word where Param stands for very small and Anu stands for particle. So very small particle, we call it as Parmanu. But later, there was a Greek philosopher somewhere in 430 BC. He was the one who named it as atoms, where atomos is a Greek word which stands for uncuttable, something which you can't cut it further. And from there, we got a new word that is atoms, and today we name it as atom itself. So everything in our surrounding is made up of a tiny particle called as atoms. Okay, so guys, this atom is the basic building structure of an element or the basic building structure of a matter. And now this atom further consists of particles such as protons, electrons and neutrons. Okay, so guys, let's understand something about such an important thing, that is atoms. Okay. Now when I say atom, as I said, atom further consists of three important particles, and these three important particles which we were talking about, it is protons, electrons and neutrons. Fine. Now we already know the structure of an atom. We have a nucleus. It's a central part of an atom, and people says that this is something really very important. Okay, why very important? Because the entire atom's mass is concentrated in this particular center. Okay, guys, am I audible to everyone clearly? Okay, Radesh, in that case, better just check your net connection. Yeah, okay, just check your net connection. All right, now around this nucleus we will be having shell, or we can also call it as orbit. Fine. So around the nucleus we have a shell, we have orbit, where the electrons are going to revolve. Okay, now the nucleus consists of protons and neutrons, and the extra nuclear part or the shells consist of electrons. Fine. So this is something very important, or a basic which we already know. Now what exactly these things are called as? Well, there is a very important word called as atomic number. Atomic number is denoted by letter Z. Letter Z stands for atomic number, which in turn called as total number of protons or electrons. I repeat, total number of protons or electrons. Matlab Z is equals to P is equals to E. For example, if I have an element hydrogen, let's say hydrogen is having one proton, one electron. So obviously its atomic number is going to be 1. Fine. So in case of hydrogen, the value of Z is also 1, value of P is also 1, value of E is also 1. Okay. Now, apart from that, there is one more very important term which we should know, and that is atomic mass number. It is denoted by letter A, and it says that atomic mass number is equals to total number of protons and neutrons. Total number of protons and neutrons. There was one scientist by the name Niels Bohr. Must have studied about him. Mr. Niels Bohr was the one who said that an atom consists of equal number of protons and electrons. He said that an atom consists of equal number of protons and electrons. Only the number of neutron will be different. So हम atom को present कैसे करते हैं? How do we present an atom? In chemistry, guys, we avoid writing long things. We generally prefer writing short forms. Fine. So in chemistry, if I want to represent a particular element, then how will I do that? For example, sodium. The symbol of sodium is Na. The atomic number of sodium is 11, and atomic mass number of sodium is 23. So how do we write? The symbol of element, atomic mass number on the top corner, atomic number on the down corner. And this is how we represent an atom. And how do we read an atom? For example, if I want to read sodium, I'll read sodium as sodium 23. If I want to read carbon, then in case of carbon, I will read it as carbon 12. Why is it so? Just for general knowledge, guys, there are certain elements जो है तो सेम बट एटॉमिक मास अलग है. यस गाइस, यानी जैसे जुड़वा होते हैं, या सो एलिमेंट्स में भी जुड़वा होते हैं. आई विल टेल यू हाउ. हियर आई हैव अ ट्रिपलेट ऑफ हाइड्रोजन. These are triplets. Their atomic number is same, but their atomic mass number is different. This is called as protium, this is deuterium, and this is tritium. Absolutely correct, guys. You are absolutely correct. Super, super amazing. They are called as isotopes. They are called as isotopes. So isotopes are the atoms of same element having same atomic number but different atomic mass number. So they are called as isotopes. Alright. Well, but we are today going to focus only and only on atomic number. So let's focus on atomic number, guys. Atomic number, as I said, it is called as either number of protons or number of electrons. Where electrons are further divided or distributed in different shells, which is called as electronic configuration. So what is electronic configuration? Distribution of electrons. Now, for example, if I want to distribute electron, there's a rule called as 2n square, where n stands for number of orbits. Okay. So let's say I have first shell, that is K shell. Okay. So what I'll do, instead of n, I will write 1. Now just use a formula here, 2 into 1 square. So simple maths, guys, 1 ones are 1, 1 twos are 2. So we'll get the answer as 2. So this is the capacity of the first shell. First shell can accommodate only and only 2 electrons, not more than that. Okay. Then I have second shell, which is called as L shell. L shell is the second shell. So instead of n, I'll just write 2. Instead of n, I'll just write 2. So when I write it as 2 into 2 square. So 2 twos are 4, 4 twos are 8. So the capacity of this shell, absolutely correct, it is 8 electrons. It can accommodate only and only 8 electrons, not more than that. Now you have to answer my question, guys. M shell, that is third shell. Come on, tell me what will be the capacity here. No, wrong part, wrong Gaurangi. Check your calculation. Yashita, absolutely correct. Manthan, Urvi, correct. Yes, Gaurangi, you got it correct now. Yes, Rachit, I'll do that. Don't worry. Jia, mistake hai. Granth, mistake hai. Parth, Shaurya, correct. Sneha, it's a big mistake, Sneha. Just check again. It's a simple form, guys. हमें सिर्फ इस rule को follow करना है, इस rule को 2n square को follow करना है. So when I say M shell, it is third shell. So what I'll do, instead of n, instead of this n, I'll write 3. Why? Because it is third shell. So it is 3 square. Now 3 threes are 9. So it becomes 2 into 9. 2 nines are 18. So answer आया 18. So Jia, it is 18. Sneha, it is 18. Okay, Rachit, I hope you understood now. What we did is, we just simply followed the formula. Formula is 2n square. Instead of n, we have to just write the number 1, 2, 3, 4, so on. Okay. Suppose, for example, if I move to the next shell, let's say it is n shell. N का मतलब हो गया fourth shell. So अब मैं क्या करूँ? Instead of n square, I will write 4. So I'll write 2 into 4 square. Fine. So it becomes 4 4s are 16, 16 2s are 32. तो मैंने क्या किया, 2n square में n की जगह पे मैंने लिखा 4. अगर n की जगह पे हम 1 लिख सकते हैं, n की जगह पे 2 लिख सकते हैं, n की जगह पे 3 लिख सकते हैं, n की जगह पे 4 लिख सकते हैं. तो इलेक्ट्रॉन को डिस्ट्रीब्यूट करने के लिए वी हैव अ रूल, and this rule gives you maximum capacity of those shells. You cannot accommodate more than that many electrons. All right. Okay. Now there is somebody जिसने बहुत बड़ा doubt type किया है. Let me just read the doubt. Ronit. Okay. It is that if the atomic number is in the even, that must be double. But the atomic number is odd, then we have to double and have to add 1. Ronit, but this trick doesn't work for all the elements. So we cannot count on that part. Okay, because there are many elements which doesn't follow the same technique. That is why we cannot remember atomic mass on that ground as such. Yeah, but idea is good. Super. Okay, but as I said, guys, this is the maximum capacity of the shell. Okay, for example, here we go. When I say maximum capacity of the shell, suppose if I talk about the first shell, maximum it can accommodate 2 electrons. But what if it is the outermost shell? Now, what do you mean by this? Suppose there is an atom having the first shell, and the first shell itself is the last shell. जैसे hydrogen है, first shell itself is the last shell. Okay, so what if the same shell is the last shell? यानी अगर first shell last shell है, second shell last shell है, third shell last shell है, fourth shell last shell है, तो क्या? तो ऑब्वियसली फर्स्ट शेल अगर लास्ट है उसका मैक्सिमम कैपेसिटी भी 2 ही है, तो उसका मिनिमम कैपेसिटी भी 2 ही रहेगा. So the first shell, if it is the last shell, it can accommodate 2 electron at least. And if rest of the shells, that is second, third or fourth, rest of the shell are the last shell, then they cannot have more than 8 electrons. I repeat, they cannot have more than 8 electrons. Okay, ऐसा क्यों? Fine, just for general knowledge, guys. When I talk about an atom, in an atom, electrons are continuously revolving. Now, while revolving, they develop an energy, and during that state, उस energy को use करके electron jump करता है. It jumps up. Okay, ये generally होता है after 8 electrons. मतलब अगर 8 से ज्यादा electron हो जाए तो ये process शुरू होता है. So if the last shell has more than 8 electron, तो वो jump करके कहाँ जाएगा? This is just for general knowledge, just to understand the logic, nothing else. Okay. So just for that reason, people says, rather scientists have also observed in the compound microscope that the last shell can't have more than 8 electron. And shell एक imaginary path होता है, कोई सच्ची मुच्ची का रस्सी नहीं होता है. It is just कि जब atom घूमता है, I mean electron जब revolve करता है, तो वो एक line जैसा दिखता है. You must have played in Diwali, वो फुलझड़ी होता है, हम ऐसे फुलझड़ी को जला के ऐसे ऐसे करते हैं at times. तो आपने ऑब्जर्व किया होगा, जब ऐसे करते हो ना तो ऐसे सर्कल बनता हुआ दिखाई देता है. एक्चुअली सर्कल नहीं है, वो दिख रहा है. क्यों दिख रहा है? बिकॉज व्हेन यू आर रिवॉल्विंग समथिंग कंटिन्यूअसली, तो उसका शेप, उसका पाथ दिख रहा है हमें. So exactly same thing happens in case of electron also. There is no actual line or there is no actual thread over there. It is just an imaginary path where the electrons are traveling. So electron होगा तो path बनेगा, electron नहीं होगा तो path नहीं बनेगा. Simple as that. Okay. So keep that rule in your mind, that there is something called as 2 electron, which is the last capacity for the first shell, and we call it as duplet state. I repeat, we call it as duplet state. And when I say 8 electron, we call it as octet state. Okay. अब ये duplet और octet मेरे किस काम का? To understand, yes Rachit, I'll do that. To understand the word valency. हमने ये इतना बड़ा डिस्कशन क्यों किया? इस वर्ड तक पहुंचने के लिए किया गाइस. अब हम वैलेंसी को समझ सकते हैं. नाउ व्हाट इज वैलेंसी? वैलेंसी इज अ कंबाइनिंग कैपेसिटी ऑफ एन एलिमेंट. इन ओल्डन डेज जब हमारे पास ये प्रोटॉन इलेक्ट्रॉन नहीं था, एट दैट टाइम, सपोज इफ आई हैव वन क्लोरीन and let's say this one chlorine will combine with one hydrogen, so combining capacity of this chlorine is 1. Suppose if I take oxygen, one oxygen combines with two hydrogen. So combining capacity of this one oxygen was 2. Similarly, one nitrogen can combine with 3 hydrogen. So combining capacity of this nitrogen was 3. So in this way, guys, we can easily identify the combining capacity, but this was not the correct method because we can't see hydrogen, we can't see chlorine, we can't see oxygen or nitrogen. So this is not the correct way to identify the valency. Later, scientists came to know about electrons. So based on electronic configuration, we can identify valency, that is combining capacity. Now how? There are some minimum capacity of the element. If an atom has exact 4 electron in its last shell, okay, or if an atom has 1, 2 or 3 electron in its last shell, that is less than 4, and if an atom has more than 4 electron in the last shell, that is 5, 6 or 7 electron, based on this we can identify. Now how? हमें सिर्फ एक फॉर्मूला याद रखना है, that is GST. Yes guys, GST याद रखना है. ये GST वो हमारा CA अंकल वाला GST नहीं है guys. This GST is giving, sharing, and taking. This GST stands for giving, sharing, and taking. So हमें this GST याद रखना है. Less than 4 electron will always give electron. Grant will come to that word. Wait for a second. More than 4 electron will take electrons. And exact 4 will always share electrons. अच्छा कितना शेयर करेगा? 8 बनाने के लिए जितना चाहिए उतना शेयर करेगा. So it needs 4 electrons. So it is going to share 4 electrons. So that is going to be its valency. Exact 1 electron, so will donate 1 electron. If there are 2 electron, will give 2 electron. If there are 3 electron, will give 3 electrons. This is the valency. Same way, if there are 5, 8 बनाने के लिए an atom needs 3 electron. To make 8, atom needs 2 electron. To make 8, atom needs 1 electron. So this is the valency. So in a very simple terms, we can easily identify valency based on this concept. Less than 4, give electron. More than 4, take electron. Exact 4, share electron. But after giving, an atom becomes positively charged ion, which is famously called as cation. Same way, after taking electron, an atom becomes negatively charged ion, which is called as anion. So, just for your knowledge, remember, metals are always electropositive and non-metals are always electronegative. I repeat again, metals are always electropositive, non-metals are always electronegative. Okay, guys, if you want, you can just take a screenshot of this, then we'll move further. Yes, Urvi, hydrogen can be considered as exception, but we cannot say it is not electronegative. It is electronegative as well as electropositive. Yes, Ronit, do you want me to unmute you? Rachit, it can cater both characteristic. It can be electropositive, it can be electronegative, Rachit. Yes, both is okay. There are no exceptions, Sanika. हाइड्रोजन दोनों कैरेक्टरिस्टिक पोजेस कर सकता है. हाइड्रोजन इलेक्ट्रॉन लूज आउट भी कर देता है, हाइड्रोजन गेन भी कर लेता है. हाइड्रोजन जनरली प्रेफर शेयरिंग ओनली, but unfortunately because of its less power, there are many atoms which are powerful than hydrogen. They take away its electron after sharing, जिसकी वजह से वो इलेक्ट्रोपॉजिटिव बन जाता है, बट वो पर्पसली कभी इलेक्ट्रॉन डोनेट नहीं करेगा. Yes, sodium is cation. Na plus is cation. Positive मतलब cation, negative मतलब anion. All right, guys. Now we'll move a step further. So we understood how do we get the valency. Ronit, M shell का maximum capacity 18 है. For example, if I write the electronic configuration of rubidium, okay. So rubidium की electronic configuration में you will get 2, 8, 18, 8, 1. आपको ऐसा इलेक्ट्रॉनिक कॉन्फ़िगरेशन मिलता है. तो यहाँ पे देखो, ये वाला शेल, थर्ड शेल 18 इलेक्ट्रॉन्स आया, बट अगर मैं लास्ट वाले शेल में 9 करूं तो नहीं चलेगा. इसलिए लास्ट वाले शेल का एक इलेक्ट्रॉन और आगे चला गया, राइट? सो इट इज जस्ट कि लास्ट शेल में 8 होना चाहिए. देन इट मे बी K शेल, L शेल, M शेल, N शेल, लास्ट वाले शेल में एक्सेप्ट K शेल, लास्ट वाले शेल में 8 इलेक्ट्रॉन्स ही होना चाहिए. Okay. Now guys, this was the basic capacity what we understood here. No Pranjal, carbon will generally prefer sharing. बहुत रेयर कंडीशन में कार्बन विल टेक इलेक्ट्रॉन. डोनेट करना तो बहुत डिफिकल्ट है, बट टेक कर सकता है. I mean it can receive electron at least, but generally 99% of the time carbon prefer sharing. Okay. Now I'll give you one more very interesting point here. थोड़ा ध्यान से देखना guys. This is something really very interesting, right? Suppose if I talk about an element iron. Iron atomic number is 26. So let us distribute electron here. First shell capacity 2, second shell capacity 8. 2 plus 8, 10 हो गया. 26 minus 10 करोगे तो आंसर आएगा 16. And as we already calculated that last shell can have, I mean third shell capacity is 18 electron. But अगर मैं यहाँ पे 16 रखूँ तो ये last shell हो जाता है. और last shell can't have more than 8 electrons. So what I'll have to do now? I'll have to redistribute. मतलब ये electrons transfer करने पड़ेंगे. अब इलेक्ट्रॉन का ट्रांसफर इज नॉट इजी कि यहाँ से उठा के यहाँ पे रख दिया. नो, इट इज नॉट दैट इजी कि हम फर्स्ट बेंच से उठ के सेकंड बेंच पे चले गए. इतना इजी नहीं है. इलेक्ट्रॉन्स आर कंटिन्यूअसली रिवॉल्विंग एंड उसको थर्ड शेल से फोर्थ शेल में यानी नीचे से ऊपर जंप करना है with the same process, with the same motion. Okay, so it requires lot of energy to do this. So based on the amount of energy present with an atom, I repeat, based on the amount of energy present with an atom, certain number of electrons will shift from second last shell to last shell. So as per that, आयन के पास सिर्फ उतना एनर्जी था कि वो 2 इलेक्ट्रॉन को शिफ्ट कर सकता था. उससे ज्यादा इलेक्ट्रॉन को शिफ्ट नहीं कर पाया. So the configuration became 2, 8, 14, 2. Now when ion will try to react with some atom, so what will happen? It will lose this 2 electron and will become ion 2 plus. So this is the valency of ion. But अगर आयन को बहुत ज्यादा हीट किया जाए, एक्सट्रीम हीट प्रोवाइड किया जाए, in that condition heat is as good as energy. So when you provide extreme energy to this ion का एक और इलेक्ट्रॉन डोनेट हो जाएगा, but that too from its second last shell, and that second last shell is called as penultimate shell. तो हो सकता है बहुत ज्यादा एनर्जी प्रोवाइड करने के बाद आयन एक और इलेक्ट्रॉन शिफ्ट कर दे और उसका वैलेंसी 2 की बजाय हो जाए 3. दिस इज कॉल्ड एज वेरिएबल वैलेंसी. वेरिएबल वैलेंसी मींस an atom can possess more than one valency. I repeat, an atom can possess more than one valency. We have few atoms who does this process, जिसके साथ ये हादसा होता है. ऐसे कुछ एलिमेंट है हमारे पास. We'll definitely talk about those elements. I mean, I'll display the list of those elements in a while. Okay, but I hope you understood the concept of valency, guys. I am erasing everything which is there on the screen. I am erasing everything what is there on the screen. Okay, all right. So valency depends upon electronic configuration. It depends upon the last electron. Last electron is called as valence electron. So valency depends on valence electron based on the stability concept, that is duplet state or octet state. So Rachit, here we have a spelling of duplet and octet. You can just check out duplet and octet state. We have only one element with the duplet state, that is helium, and we have few element, that is neon, argon, krypton, xenon and radon. So there are 5 elements which are in octet state. Matlab they have 8 electron in their outermost shell. Okay, so every atom will try to attain that kind of configuration. For that we just have to remember G, S key, G for giving, S for sharing, T for taking. So here we have valency of few elements. Hydrogen valency 1, helium 0, lithium 1. Helium 0 क्यों guys? Duplet state है. वो ना give कर सकता है, ना take कर सकता है, ना share कर सकता है. There is no need rather. मतलब उसके पास बहुत पैसा है, उसको जरूरत नहीं है. Yeah. Same way, even neon will not undergo. Last shell में 4 है ना प्रांजल, तो वो share करेगा. Generally, it will prefer sharing of electron. Yes, Virat, configuration of ion is going to be 2, 8, 14, 2. Okay, guys, what I have done, I have displayed one valency chart. I'll just display that valency chart. Here we go. Yeah. So what I want is valency chart ka. There are 3 chart of, rather 4 chart. I just want you all to take a screenshot of this. Okay, iska screenshot le lijiye, guys. This is the first chart. Just take a screenshot. Okay, this is second chart, guys. Valency 2. The first chart was having all the elements with valency 1. This is the second chart having elements with valency 2. Okay, now this is third chart. It is having valency 3. Carbide is carbon, Rachit. And this is the last chart with variable valencies. Sorry, yeah. So just take screenshot of this. Yes, Pranjal, metals are always donor and non-metals are always receiver. Non-metals can also undergo sharing, but metals generally don't do that. I'll explain Yashita in a while. Yeah, metalloid generally we have different metalloids. Some metalloids are donor, some metalloids are receiver, and those who generally receive they can share also. Okay, I assume that everybody has taken a screenshot of this. Now, why this screenshot was required? Well, this is very important, guys. As I said, it is a base of chemistry. We must know this very carefully. We must remember all the valencies and symbols. And this is really very important, guys. Okay. So for that, what I've done, I've tried converting this into a small tune. Fine. uh, Probably हमें गाने बहुत जल्दी बैट हो जाते हैं, that is what my assumption. Fine. So शायद हमें symbol और valency भी जल्दी बैट हो जाए, because unless and until we know symbol and valency we cannot write molecular formula. Yes, it is really very important for us. Okay. तो बहुत इंपॉर्टेंट है, बेस है। तो चलो एक काम करते हैं, थोड़ा सा भगवान को याद कर लेते हैं पहले, उसके बाद हम आगे बढ़ते हैं। या वैसे भगवान को याद करने के लिए मुझे कोई आरती बिरती नहीं आती है, तो मैंने एक काम किया, मैंने खुद की आरती बनाई है। या सो गाइस, हियर वी गो। 1 2 3, लेट्स स्टार्ट। OH hydroxide, Cl chloride, Br bromide, I iodide, no 3 nitrate, I iodide, no 3 nitrate, HCO3 bicarbonate, बोलो HCO3 bicarbonate, AlO2 aluminate, Ag silver, Na sodium, H hydrogen के पोटेशियम, H hydrogen के पोटेशियम, Li है लिथियम, NH4 अमोनियम, ClO hypochlorite, HSO3 bisulfite, HSO4 bisulfate, ClO3 है क्लोरेट, MnO4 पर मैंगनेट, इन सब की वैलेंसी है ए। Once again I repeat guys, OH hydroxide, Cl chloride, Br bromide, I iodide, no 3 nitrate, I iodide, no 3 nitrate, HCO3 bicarbonate, बोलो HCO3 bicarbonate, AlO2 aluminate, Ag silver, Na sodium, H hydrogen के पोटेशियम, H hydrogen के पोटेशियम, Li है लिथियम, NH4 अमोनियम, ClO hypochlorite, HSO3 bisulfite, HSO4 bisulfate, ClO3 है क्लोरेट, MnO4 पर मैंगनेट, इन सब की वैलेंसी है एक। नेक्स्ट चार्ट, U यूरेनियम, Ca कैल्शियम, Mg मैग्नीशियम, Ni nickel cobalt causing Zn, Ni nickel cobalt causing Zn, Ba है बेरियम, बोलो Ba है बेरियम, S सल्फाइड, O ऑक्साइड, O2 है पेरोक्साइड, SiO3 सिलिकेट, SO3 सल्फाइड, SiO3 सिलिकेट, SO3 सल्फाइड, PbO2 है प्लम्बाइड, बोलो PbO2 है प्लम्बाइड, Cr2O7 dichromate, CrO4 chromate, बोलो CrO4 chromate, CO3 carbonate, SO4 sulfate, CO3 carbonate, SO4 sulfate, जिंकेट है ZNO2, इन सब की वैलेंसी है 2। Once again I repeat, U uranium, Ca calcium, Mg magnesium, बोलो Mg magnesium, Ni nickel cobalt causing Zn, Ni nickel cobalt causing Zn, Ba है बेरियम, बोलो Ba है बेरियम, S सल्फाइड, O ऑक्साइड, O2 है पेरोक्साइड, SiO3 सिलिकेट, SO3 सल्फाइड, SiO3 सिलिकेट, SO3 सल्फाइड, PbO2 है प्लम्बाइड, बोलो PbO2 है प्लम्बाइड, Cr2O7 dichromate, CrO4 chromate, बोलो CrO4 chromate, CO3 carbonate, SO4 sulfate, CO3 carbonate, SO4 sulfate, जिंकेट है ZNO2, इन सब की वैलेंसी है 2। PO4 phosphate, N is nitride, PO3 है phosphide, बोलो PO3 है phosphide, aluminium AlCr chromium, aluminium AlCr chromium, सबकी वैलेंसी है 3, but carbide shows valency 4, बोलो केमिस्ट्री माता की। J. Yes. Thank you, Rachit. Thank you, Sana. But trust me, guys, this is the best way to remember what I feel. You can remember symbol, you can remember valencies, you can remember the formula as well. Yeah, that is symbol, of course, and the name also. Yeah, super. Thank you so much, Himanshu. Thank you, Rachit. Thank you, Manthan. Thank you. Thank you so very much, guys. Thank you so very much. Thank you, Rachit. Thank you so much. Definitely, Ronak. Definitely, yes. Definitely, yes. Oh, wow. Thank you so much, Pranjal. Okay. So, guys, this is how we can easily remember all these valencies and symbols, right? Okay. Now, this is a symbol of variable valency. यहाँ पे एक सबसे important चीज याद रखना, guys. We have certain elements with valency, double valency. Okay. But question arises, which valency I am supposed to use where? कौन सा valency मैं कहाँ पे use करूँ? This is one of the big question here. So यहाँ पे when I talk about valency to be used in olden days, people were using this concept. For example, I'm talking about copper. Copper has two valency, one and two. The small one is one and the bigger one is two. When chota valency is one, bada valency is two. Okay. So old method, the oldest method was people were writing in this way: Cuprous, OUS. When the suffix is OUS, out of two valency, we have to use the one which is the smaller one. So we were using one. And when I say cupric, when the suffix is ik, sorry, when the suffix is ik, then we will use bigger valency, that is two. Okay, I repeat again. Cuprous, valency one, cupric, valency two. So us valency, small valency use होगा, एक bigger valency use होगा. Right? So in this way we can remember the valency. But this was old method. After that, there is something called as IUPAC. IUPAC is International Union of Pure and Applied Chemistry. इसका काम होता है नामकरण करना. मतलब किसी भी एलिमेंट का नाम, कंपाउंड का नाम या कोई भी सिंबल हम उसके अप्रूवल के बिना यूज नहीं कर सकते. Unless and until IUPAC approves it, authenticates it, we cannot use that symbol or a name. So as per IUPAC, now we write in this way like copper 1, copper 2. तो देखो ये 2 का मतलब उसका वैलेंसी 2 है और ये 1 का मतलब उसका वैलेंसी 2 है. So for mercury we will write mercury 1, mercury 2. For silver we will write silver 1, silver 2. Fine, same way. Okay. Now, no, 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 no. Old naming system was ferric and ferrous. फेरिक नहीं, फेरिक में बड़ा आता है वैलेंसी. प्रांजल, फेरिक में बड़ा वैलेंसी आएगा, यानी फेरिक इज 3 एंड फेरस इज 2. OUS छोटा वैलेंसी, IC इज बिगर वैलेंसी. ओके. अच्छा, अब जो मैंने यहाँ पे सर्कल किया है, मैंने सिर्फ उन्हीं एलिमेंट्स के अंदर सर्कल किए जो हम कॉमनली यूज करते हैं. तो कॉपर का कॉमन वैलेंसी जो हम यूज करते हैं नॉर्मली, अगर कुछ भी मेंशन नहीं किया, देव जस्ट रिटन कॉपर क्लोराइड, कॉपर ऑक्साइड, देन व्हिच वैलेंसी वी वुड बी यूजिंग? वी वुड बी यूजिंग द सर्कल्ड वन, दैट इज 2. सेम में मर्क्यूरी का कॉमन वैलेंसी, जनरल वैलेंसी इज 2. सिल्वर का जनरल वैलेंसी इज 1. आयन का जनरल वैलेंसी इज 2. लेड का जनरल वैलेंसी इज 2. So these are some common elements and their common valency. The one which are circled, Yashita, you had asked this question. The one which are circled, circle इसलिए किया है, जो वैलेंसी पे सर्कल किया वो कॉमन वैलेंसी है. अगर कुछ भी मेंशन नहीं किया है, 1 2 2 3 ऐसा कुछ भी मेंशन नहीं किया है, then we will use the one which is circled. Okay. Now, where do we use these valency? Why do we need it? Okay. A while ago in the beginning, somebody had asked me that why can't we write H2O2? Why can't we write 2HO? Iska reason is valency, guys. When the combination happens, that combination happens based on valency. Okay. So whenever the compound is formed, there are two radicals observed. One is cation, that is positive radical, and one is anion, that is basic radical. So most of the compound has the same strategy. एक पॉजिटिव होता है और एक नेगेटिव होता है जो आपस में कंबाइन होता है. पॉजिटिव नेगेटिव अट्रैक्ट ईच अदर. ओके. तो इसका नेमिंग, इसका फॉर्मूला कैसे बनेगा? फॉर एग्जांपल आई वांट टू राइट सोडियम सल्फेट. So sodium is positive, sulfate is negative. Okay. So first we need to write sodium, that is Na. As we can see here, हमने यहाँ पे लिखा है Na और यहाँ पे लिखा है sulfate, that is SO4. Okay. Sodium valency is 1, sulfate valency is 2. एक सबसे important point, positive हमेशा left side में आता है, negative हमेशा right side में आता है. Repeat again, positive is always on the left side, negative is always on the right side. You have to keep this logic in mind. Positive is always on left side, sulfate SO4 is always on the right side. Okay. So here we have Na valency is 1, SO4 valency is 2. Okay, we just have to crisscross. When we will crisscross, we will get Na2 SO4. When we will crisscross, we will get Na2 SO4. Okay, हमने valency का exchange किया, valency का number exchange किया. Okay, let's take few example to understand this. The example over here we need to understand is potassium hydroxide. Okay, so first we need to write the symbol of potassium, that is K. Hydroxide is OH. कहाँ से मिला symbol हमें? हमारा आरती OH hydroxide. What is potassium? H hydrogen, K potassium. H hydrogen, K potassium. So K is potassium. Valency of potassium is 1. Hydroxide valency is 1. Now simple, we just have to exchange the valency. When we exchange the valency, we will get K1 OH1. But we don't represent 1, so obviously formula becomes KOH. So that's how we write the formula KOH. प्रांजल जनरल यानी जो कॉमन वैलेंसी हम लोग हमेशा यूज करते हैं, जैसे पोटेशियम का कॉमन वैलेंसी हमेशा हम 1 ही यूज करते हैं. वैसे कॉपर में हम ज्यादातर 2 ही यूज करते हैं. रेयरेस्ट कंडीशन में 1 यूज होता है. दैट रेयरेस्ट कंडीशन हम वक्त आने पर देख सकते हैं. नॉट नीडेड राइट नाउ. फाइन, समवेयर इन 10th स्टैंडर्ड जरूरत पड़ता है उसका, तब हम उसके बारे में बात कर सकते हैं. For tin also we generally use 2. But that is not the commonly used element. मतलब हमारे सिलेबस में बहुत ज्यादा ऐसे यूज उसका 10 का नहीं आता है, इसलिए मैंने उसको सर्कल नहीं किया था. Okay, next we have here, it is magnesium chloride. Magnesium is Mg, chloride is Cl. Magnesium valency is going to be 2, chloride valency is 1. Just simple crisscross, you will get MgCl2. That is magnesium chloride. Okay, so guys, now I will give you compound. You have to give me the formula. All right. Okay, here we have silver nitrate. Perfect, Parth, Virat, absolutely correct. Still I'm waiting for answers. Rachit, that is what you made a mistake there. रचित हमें सिंबल यूज करना होता है बेटा, हमें वैलेंसी के लिए सिंबल यूज करना होता है. जैसे हमने वैलेंसी चार्ट में अभी थोड़ी देर पहले देखा था दैट AlO2 aluminate, Ag silver, Na sodium. Ag is silver. Ag silver का symbol is not S, silver का symbol is Ag. There are certain element हमने पढ़ा होगा हमारे 8th स्टैंडर्ड में कि जिसका नाम और जिसका सिंबल मैच नहीं होता है. सिल्वर हम लोग Ag लिखते हैं बिकॉज उसका रियल नेम इज आर्जेंटम. ओके, yes, Latin name, perfect Virat. Yeah, and nitrate, I iodide and no 3 nitrate, no 3 nitrate, I iodide no 3 nitrate, no 3 nitrate. So nitrate is NO3. So Ag ka valency 1, nitrate ka valency 1. Now when you crisscross, you get the formula as AgNO3. Okay. So Rachit, we have to use valency chart beta. Okay. Same way, here we have next aluminium oxide. Come on guys, you give me the formula. If it is not mentioned Virat, then we will have to use the common valency, the general valency, the one which we have circled. Parth, you made a mistake beta. Yashvi, you made a mistake. एल्यूमिनियम AlCr chromium सबकी वैलेंसी है 3. एल्यूमिनियम वैलेंसी is 3. O oxide, S sulfide, these are valency 2. Fine. Now you crisscross, you will get Al2O3. That is aluminium oxide. So the formula is Al2O3. विराट OH नहीं आएगा बेटा, हाइड्रोक्साइड नहीं है, ऑक्साइड है, ऑक्साइड. Okay. Okay. Now I'll give you one more very important substance. ध्यान से सुनना what I'm doing here. It is ammonium sulfate. Okay, now when I say ammonium, ammonium is NH4. Sulfate is SO4. From where did I come to know about it? Valency chart. H hydrogen के potassium, Li है lithium, NH4 ammonium. Then CO3 carbonate, so4 sulfate, so4 sulfate. Okay. Now ammonium valency is 1, sulfate valency is 2. Now when you crisscross, this is called as group radical guys. And when you have group radical, in that situation, when you have group radical, okay, here I have a group radical. So group radical को bracket बनाना होता है if the number after crisscrossing is bigger than 1. You cannot directly write NH4 2. You have to make a bracket because this 2 is applicable to hydrogen as well as to nitrogen. Fine. So this is how we will write the formula NH4 twice SO4. SO2 नहीं आएगा, SO3 नहीं आएगा, SO4 आएगा. SO2 का मतलब होता है सल्फर डाइऑक्साइड, SO3 का मतलब होता है सल्फाइट एंड SO4 का मतलब होता है सल्फेट. हमें ये नाम और सिंबल बहुत अच्छे से लर्न करना है गाइस. अगर हमें नाम और सिंबल आते हैं तो हम बहुत इजीली फॉर्मूला बना सकते हैं. नो गौरांगी, इट इज रॉन्ग बेटा. अमोनियम इज NH4 एंड सल्फेट इज SO4. तो अमोनियम के यू कैन नॉट चेंज फॉर्मूला. ये चीज याद रखना, फॉर्मूला चेंज नहीं हो सकता है, आपको सिर्फ वैलेंसी को क्रिस क्रॉस करना होता है. यू कैन नॉट चेंज द फॉर्मूला, यू जस्ट हैव टू क्रिस क्रॉस वैलेंसी. ऑलराइट, सुपर सुपर. नाउ where exactly we use this chemical formula? Of course we use these chemical formulas in chemical equation. Now when I use chemical formulas in chemical equation, What is chemical equation? So here, it's a basic short form of chemical reaction. I repeat, it is the short form of chemical reaction. It is a way to represent chemical reaction. So here we have one small reaction where it says that there are two sides, left hand side and right hand side. On the left hand side, we have two substances. They are called as reactants. On the right hand side, we have two substances. These are called as products. So reactants are always on the left hand side. Products are always on the right hand side. Next, there can be more than two or more than two reactants. So they'll be separated by plus sign. Same product also, there can be two or more products that they'll be separated by plus sign. There will be an arrow. Arrow always indicates direction of reaction. I repeat, arrow always indicates direction of reaction. मतलब reaction कौन सी side पे है? It is reversible, irreversible. Which type of reaction is this? That is what has been explained by direction, by an arrow. Okay, so it represents the direction of reaction. But सबसे important चीज जो यहाँ पे फिलहाल missing थी, reaction has to be complete. In what sense I'm talking about? There was one scientist by the name Antony Lavoisier. Mr. Antony Lavoisier said that always during chemical reaction, total mass on the reactant side and on the product side remains constant. I repeat, total mass on the reactant side and the product side always remains constant. That is what Mr. Antony Lavoisier had to say. This was the law of conservation of matter, which says matter is neither created nor destroyed during any chemical reaction. कोई भी substance ना गायब हो सकता है, ना extra add हो सकता है. It has to be same, equal. Only formula changes, the compound changes. That's the basic change what we observe. Okay. मतलब total number of atoms same होने चाहिए on both sides. तो ही mass same हो सकता है. To get the total number of same atom, we need to balance equation. क्योंकि जब हम फॉर्मूला लिखते हैं, हम वैलेंसी यूज करते हैं, जिसकी वजह से रिएक्शन बैलेंस इम्बैलेंस होने के चांसेस है. तो हमें इक्वेशन को बैलेंस करना पड़ता है. अब इक्वेशन को बैलेंस कैसे करेंगे? लेट्स अंडरस्टैंड. For balancing of equation, we have two important methods here. One is called as hit and trial method, and the second is called as partial equation method. We commonly, मतलब ज्यादातर, almost each and every reaction, we use only one method, that is hit and trial method. Partial equation is the rarest method, जो वक्त बहुत ज्यादा, मतलब जब आप 11th 12th में जब शायद जाओगे और वहां पर अगर हमें जरूरत पड़ा और हमने यूज किया तो चलेगा. 9th स्टैंडर्ड में एक छोटा सा टॉपिक है पार्शियल इक्वेशन करके, बट हमें एक ही लॉजिक पे प्रेफर करना है, एक ही लॉजिक को फॉलो करना है, दैट इज हिट एंड ट्रायल मेथड. ओके, now what I'll do, there are basic rules, stupid rules what I have made for the balancing, which I would love to share with you all. Okay, rule number 1 for balancing: always go from left to right. While balancing, always go from left to right. This is first rule. Okay, rule number 2: you can always multiply number. I repeat, you can always multiply number. You cannot add, subtract, divide. Okay, you can always multiply number before formula. I repeat, you can always multiply number before formula. पूरे फॉर्मूला के आगे आपको नंबर मल्टीप्लाई करना होता है. Rule number 3: after writing any number, this is my rule, after writing any number, look at the बाजू वाला. I repeat, after writing any number, look at the बाजू वाला. Okay, in short, look at the neighboring atom, guys. Last one: if you don't get any number to multiply, then search odd number. Search odd number and odd को बनाओ even. Odd को बनाओ even. How? By multiplying 2. By multiplying 2. Odd को बनाओ even. How? By multiplying 2. Okay, so these are some stupid rule which what I follow normally. Okay, so let's start. balancing some important equations. Okay. No, Rachit, you will get confused. You will not get which number to be multiplied. That is why I made this simple strategy कि आप odd को even बनाओ, automatically समझ में आ जाएगा which number is to be multiplied. Okay, let's start. Suppose if I want to balance this equation, Urvi, that is what I'm saying, that always apply this strategy. Trust me, you will get the balancing easily. ऐसा कोई strategy नहीं है कि आप ऑक्सीजन को एंड में बैलेंस करो या हाइड्रोजन को एंड में बैलेंस करो. बैलेंसिंग करते वक्त इतना ध्यान रखो कि आप लेफ्ट टू राइट जाते हो तो ऑटोमेटिकली आंसर मिलता जाएगा. किसी को एंड में बैलेंस करना है तो यू विल गेट कंफ्यूज. इट्स बेटर फॉलो द लाइन. दैट्स इट. ओके, लेट्स चेक. फर्स्ट विल स्टार्ट विद हाइड्रोजन. लेफ्ट टू राइट जाना है हमें, so we'll start with hydrogen here. Hydrogen, on the left hand side we have two hydrogen. On the right hand side we again have two hydrogen. Uh-oh. Let me write equation again, guys. So sorry. H2S plus O2 gives you SO2 plus H2O. Ready, guys? Okay. On the left hand side there are two hydrogen. On the right hand side there are two hydrogen. So hydrogen is already balanced. Now let's check sulfur. Left hand side we have one sulfur, right hand side we have one sulfur. Already balanced. Let's check here. There are two oxygen on left hand side, but there are 2 plus 1, 3 oxygen on right hand side. Now see this. Obviously, we cannot multiply 2 with 2 to get 3. We cannot multiply any number to 3 to get 2. है ना, 2 के टेबल में 3 नहीं आता, 3 के टेबल में 2 नहीं आता. तो क्या करेंगे? Very simple. Search which is odd. Is this 2 odd? No. Is this 2 odd? No. Is this 1 odd? Yes. So odd को बनाओ even. कैसे? Multiply by 2. After writing any number, look at the बाजू वाला. The neighboring atom of oxygen is hydrogen. So it becomes 2 2s are 4. Check here. Hydrogen is 2 over here. Multiply this hydrogen by 2. After writing any number, look at the बाजू वाला. S becomes 2. Here S is 1. So what should we do? Simple, multiply by 2. After writing any number, again, look at the baju wala. Oxygen becomes 2 2s are 4. 4 plus 2, 6. Here oxygen is 2. How to make it 6? 2 3s are 6. See, now your equation got balanced. Did we understand this, guys? Perfect, Vedant. Perfect, Rachit. Perfect part. Super. So now I will give you equation which you have to balance. Ready, steady, go, guys. Okay, start. पार्थ नहीं चलेगा बैलेंसिंग. बैलेंसिंग हैज टू बी द लीस्ट वन बेटा. द लीस्ट पॉसिबल नंबर होना चाहिए. रचित नहीं चलेगा. द नंबर हैज टू बी द लीस्ट पॉसिबल नंबर. Perfect, guys. Absolutely correct. mg 1 on left, 3 on right. So we'll simply multiply mg by 3 on left hand side. Next, n is 2 on left, n is 2 on right. So it is already balanced. This should be the answer, guys. Check. Okay, guys, come on. You have to balance this as well. Okay, let's check, guys. Al is 1 on left, 2 on right. We'll multiply here by 2 on the left hand side. Okay, after that, H is 2 on left, 2 on right. No need to multiply any number. But we can check oxygen. O is 1 on left, 3 on right. So we'll multiply H2O with 3. When we do so, hydrogen gets affected. It becomes 6 on left, 2 on right. So multiply on right hand side with 3. This is the final answer, guys. 2Al plus 3H2O giving us Al2O3 plus 3H2. Not always, Rachit, when you don't get any number to get multiply. When we don't get any number to multiply, Rachit, that time we have to do that. Like here we can multiply 1 to 3, no? But there in that case, you cannot make 2, 3 or you cannot make 3, 2. There was no number to get multiply. That is why we made that strategy, odd ko banao even. Alright. Okay, let me give you one little difficult equation. Guys, ready? थोड़ा difficult वाला equation करते हैं. Okay. NH3 plus oxygen gives you NO plus H2O. Yes, Parth, of course. Don't worry. Okay, guys. Balance this. Kiran, balance the entire equation. Wait on it. Let everyone start. No room. It is wrong. Parth, it is wrong. Check again. Gia, it is wrong. Check again. Try, Rachit. Don't worry. I'll definitely give the answer. Okay, let's do it. All right. See, इसीलिए इसका नाम hit and trial method रखा है guys. Why do we call it as hit and trial method? This is the basic reason behind this. Yeah. Okay. See, Ronak, you will be getting a link of this entire lecture, so don't worry. In that you will get that also. Okay. N is 1 on left, 1 on right. H is 3 on left, 2 on right. Correct? Yeah. Now what should we do? Odd ko banao even, because you cannot multiply 3 to make 2. You cannot multiply 2 to make 3. So what we will do? We'll make it odd. We'll convert odd even. How? Simple. Odd is 3, so we'll multiply here by 2. Okay. After adding any number, look at the baju wala. N becomes 2. N is 1. So multiply n by 2. Hydrogen becomes 2 3s are 6. Hydrogen is 2 here. So multiply this by 3. Now check oxygen. Oxygen here becomes 3 plus 2, 5. Here oxygen is 2. So again, 5 is odd, 2 is even. 2 के टेबल में 5 नहीं आता है, 5 के टेबल में 2 नहीं आता है. तो क्या करें? Simple, odd को बनाओ even. Who is odd? Is 2 odd? No. Is this 2 odd? No. Is this 3 odd? Yes. So odd को बनाओ even. कैसे? 3 multiply by 2. 3 2s are 6. So guys, अब यहाँ पे मुझे changes करने पड़ेंगे. Instead of multiplying by 2, 3, I have to multiply here by 6. So H becomes 6 2s are 12. Here H is 3. तो मुझे इसको 12 कैसे बनाना है? 3 4s are 12. Now N becomes 4. So make this N 4. Instead of 2, we'll have to make it 4. Now check oxygen. 4 plus 6, 10. तो इसको 10 कैसे बनाएंगे? 5 2s are 10. Did we get this now? Should I repeat the entire equation? Okay, I'll repeat. I will repeat, guys. Wait. All right, let's do it again. What we did first, initially we multiplied here by 2. N becomes 2, so we multiplied 2. H becomes 2 3s are 6, so we multiplied 3 2s are 6. But here oxygen becomes 5, here oxygen becomes 2. So we'll convert odd even. Who is odd? 2 or 3? Of course 3 is odd. So what we did? Simple. We multiplied hydrogen with 3 2s are 6. So let's do that. When I multiply here by 6, hydrogen becomes 6 2s are 12. So multiply this hydrogen by 4. After adding any number, look at the baju wala. N becomes 4. Here N is 1. So let's multiply this by 4. After writing any number, check the oxygen here. Look at the baju wala. Oxygen becomes 4 plus 6, 10. Whereas here, oxygen is 2. So multiply this by 5. 5 2s are 10. Alright, guys. Now, I'm sending you one link in the chat box, guys. You just have to give that test right now itself. Okay? Wait, I'll give you the link.